All right, so today we're starting to look at our financial scenarios or situations, and the first one we're going to look at is simple interest. So you would have heard simple interest before. What simple interest is where you're always adding the same amount onto your onto your investment or whatever you're doing. Okay, so it's never changes. So say like the other day when we were talking about, he was always adding 250 into his investment. That's a simple interest. And it's a linear because if we graphed it, it would be a straight line. So what we're now going to do is we're going to look at simple interest, but we are going to use that recursive language where we have where we say the initial amount, we'll call it the principal, the VO, and then we'll have a rule for a recursion relation to find out, maybe a value in the future or things like that. So simple interest is a fixed amount over regular intervals. Now the principal is they might say the principal, and that's always the original amount. So if you want to write in there, it may be the original amount. And we often, when we're talking recursively, we'll call it VO, okay? And then the amount added, interest, is usually a percentage of the principal. So this, the same amount that we're adding is down here. So down here we've written is D in this formula. So this is the recursion, simple interest recursion basic formula here. So you can see you add the simple, this is the simple interest being added every time. Okay, and that's the D. So what we're saying, we calculate that amount is generally a percentage of the original one. So here's a formula down here on how we can calculate that D amount. So it's got a few things in here. So we're just going to go over. So VO, we know, is the initial amount. So you might just write that. That's the initial amount. And maybe in brackets you might put that it's the principal so that you remember. Okay? Okay. The Vn plus 1 is just the expression how you get the next term, yeah? Or the next value, I'll say. Or we'll say term because they're called term. Next term, or in brackets, the next value. And when you see Vn, that's generally the value you have. The value you have, or the value now. Okay? Okay, so then we've got, so that's what that is. And then D is the same amount being added, yeah? So that's what the D is. And I've put the formula there for how we calculate D. And you can see that we've got an R. So when you see the R in your formulas, R is going to be a percentage rate, yeah? Interest rate, we should say. And normally, R equals the annual interest rate. What do I mean by annual?
Yearly.
Yeah, yearly. So sometimes they might say R equals the percentage rate per annum, okay? So if you just want to write that underneath, per annum. That's another way of saying annually, okay? In finance, you'll hear a lot of the per annum. Okay, so here's an example of modeling simple interest with a recurrence relation. So we've got the scenario of simple interest, but we're gonna write it out using that recurrence relation, language. So what we want to get into a practice of is we're gonna highlight things, and you're gonna see, and then I'm gonna write underneath what that is in the recurrence relation formula. So it says Cheryl invests 5,000. So when you say she invests, that's generally the initial amount. So when you see that, let's write underneath there, we know that's a VO. So I'll write underneath that that's VO. And so Cheryl invests in an investment account that pays 4.8% per annum. So see how I said per annum? That's where they're telling you. They gave me the R there, okay? So now I know. And now the other important thing to make sure you're underlining is that it's simple interest. Obviously, this chapter is about simple interest, but you've got to remember in your exams, everything's going to be mixed up. So as long as you highlight underneath what you're doing, as soon as they say, and they will make sure they tell you, they say simple interest, you go to your formulas and you're using your simple interest formulas. Okay, so we've got them all summarized at the end of your notes, so you can go to that when it's all mixed up. All right, okay, so we know it's simple interest, but anyway, they say model this simple interest using recurrence relation. So the other thing we need to make sure is we're underlining recurrence relation. So they've given it here. So they've given us the basic template for a simple interest recurrence relation. That's here. But if you won't get that in the exam, you will be asked to go do it yourself. So you'll look at your summary sheet and you'll see this sort of information there. Okay, so all they're asking us is to write out this scenario. So when you have a recurrence relation, you must first write the VO. So we know that's 5,000. So I pop in the 5,000. And then the other thing you must have is the rule of how to get the next one. So I write Vn plus 1. And the rule is here. So here, you always write Vn. And you'll see on your summary sheet or back before, you'll see that I had the D highlighted. If something's highlighted on your formula sheet, it means you have to calculate it. And here, they've put it there, and that's a reminder of how you work it out. So what I'm going to do is work out the D on the side, what the amount is. So the formula says the rate, the R, so I do 4.8 over 100, and I have to times it by the VO, which I know is 5,000. So we do that on your calculators, that bit, and you'll work out what D is. Okay, so we ended up, that was 240. So I can finish off this recurrence formula by writing plus 240. So this is what the answer is. You must show that when they ask for a recurrence relation. You have to have VO and you have to have the n plus 1 rule, whatever it is. And this one's a simple interest. Okay, so let's have a look at this next one. So this one, it says Cheryl's simple interest. So once again, they're telling you. So it's really easy. Once they have to tell you what you're doing. So you just go, all right, I'm doing simple interest. And it says where Vn is the value of the investment after n years. Because we could be doing monthly and all that. So they're saying this is after n years. So use the model to determine the value of Cheryl's investment after 3 years. So it's very important when they say to use the model, you have to actually show the steps. So they've given me VO, which is in the initial. If I was going to find, so what I'm going to say is I'm going to find V1. And V1 would be found by using the one before, which is 5,000, or the one we have, 5,000 plus 240. So then we end up with 5,240, okay? Then you have to show that V2, so after 2 years, you would be, it's the 5,240 plus another 240. So we get 5,480. And then you have to show V3 is the 5,480 plus 240, which equals, what's that, 5,720? No? Yes? Okay, so that's how you have to, it says use the model to show. You have to write exactly what I wrote there, everything. All right, so then that was A, and then it said when will Cheryl's investment first exceed 6,000. So all you have to do is you could probably be putting this one into your calculator. So you remember when we said we typed in 6,000. Oh, sorry, 5,000 was the beginning. So you type in 5,000 and you press enter and you end up with the 5,000 over here. And then you remember, if you press, you want to add 250. If you press the plus, you should see answer, add 240. And then you're going to keep on pressing enter and you'll keep getting that. And then that's 480. You keep going until you see 6,000. And then how many times did it take to get to that 6,000? So we kept doing that and we saw this was after 1, 2, 3, 4, 5. So when will the investment first exceed 6,000, you just have to show the first one over it. So don't worry that it's not exactly, and you just say after 5 years. Okay, so that was the simple interest. That was the recurrence formula for simple interest. Now we're going to look at the simple interest, the nth term rule. So this is the rule. We'll use this to find any term at any time, yeah? Oops, sorry. To find any term at any time. So that's like what someone said before. Like, what if we're like going, they want, term 20. They won't make you do it recursively. They'll make you use the nth term formula. So you can see here's the nth term formula. So if it's highlighted, that means you need to change it when you're writing the one out. So here, the VO, that's the initial amount. And there's that D value again. And here's that formula that you use to find the D value. So the reason I just put plus and highlighted that, because simple interest is when you're adding the amount. And then you will times it by how many times you want to do it. So let's go down and have a look at this one down here. It says Annie invests 3,000 into a simple interest. So I write that's VO. And I'm also going to underline its simple interest. So I've gone to my formula sheet and I'm looking at my simple interest formula. And it says, and it's paying the interest rate of 6.5% per year. So I know that's my R, because that's the per annum rate. And it says use a rule to find the value after 10 years. So when they're saying the rule, and not recurrence relation, when they're saying the rule, that means we want the nth term rule formula, or rule, whatever you want to call it. I'm going to call it formula. So that would be when you go up to your note, your summary sheet, you've looked it up, you've got simple interest, you want the nth term. So you'd be writing what I've got up there. So you might just write this out first, and then you go, all right, Mrs. said I've got to change what the VO to what it actually is, which is 3,000. And then I have to, it'll be N times the D. So the D I need to work out again as well. Okay, so over here on the side, I'm going to work out what D is by using the formula. So it would be 6.5 over 100 times 3,000. So what does that equal? Okay, so it's 195. So the formula here would be, I don't need to put the D, I actually put times 195. Okay, so when I go to find, they want me to find what happens after 10 years. So that means V10. So if I'm changing it to V10, that means in that formula, every time I see the N, I'll put a 10. So it'll be 10 times 195, and then you work that out. Just use your calculator. It'd be 3,000 plus 195 times 10, which is going to be what? 4,950. Okay, the following recurrence relation can be used to model simple interest. So once again, they're telling me that. And here, this is a recurrence relation because they've put VO and they've put the VN plus 1 rule. there. Okay, so they're saying where the investment is after n years. Okay, good. So what is the principal of this investment? How much is added to the investment each year? So let's answer these things. So first of all, what's the principal? How much is the principal? Looking at that scenario. Good, 3,000. And how much is added every year? Yeah, so 260 added per year. So what they're testing is that you can just read a recurrence relation and you can understand what they're talking about. That's what they're asking you these questions. So B, now it says write down the rule. So see there, they're saying rule. So I know I've got to go to simple interest and write the nth term rule. So if you look back at your notes, it was Vn equaled VO plus N times the D. Yeah? So in this example, what was VO? So 3,000. And what was the D? What was D in this example? What's D? What's getting added on every time in this example? Yeah, so this would be 260. Now see how I'm writing N after, because that was like what I was talking about yesterday. We often like to write the letter after, don't we? You're not wrong if you don't do it, but that's how you'll see it, okay? So this is the rule for the value after any N years, yeah? And then it says use this rule to find the value of the investment after 15 years. So that means I want V15. So using that rule, where I see N, I'm going to put 15. Okay? And then I can find out what the value is. Plus 260 times 15. Sorry, I'm just quickly doing that. So I get 6,900. And then the last one, it says, use the rule to find when the value of the investment exceeds 10,000. So what they've given you there for this, for question D, we got given a value. So we've got a value, and they want to know, find the value, find when. So N is the question. So what I can do is I can use the nth term, the nth term formula, and what I'm saying is I want it to be 10,000, and then I write the formula, and you can see I want to know when N is. Okay, so how would we normally do that if we see something like that in our calculators? Yeah, good. Solve. So we'll just use solve, comma N, and that way we can find out how many years it does. Alright, so I get it to be 26.9. So at 26.9, it's 10,000. So it says when it exceeds 10,000. So let's just round. If I go to 27, it will exceed. So this is a scenario where you would always go up. Yeah, wouldn't you? You have to go up, because even if you're 26.1, if you go to 26, you're not there yet. Does that make sense? So we've always got to go up. So we're going to say N equals when it's 27 years. So when we'll say after 27 years.